Hi all, welcome back to software engineering course.
Today we will see the third chapter, software architecture and planning a software project. This is the marks split up. Okay. Next, the contents of software architecture are as follows. First we'll learn the role or uses of the software architecture, then architecture views, CNC view, that is component and connector view with an example, then different architecture styles of CNC view, how to document the architecture design and how to evaluate the architectures. So first we will understand what a architecture is. Okay. So whenever I ask you a question or someone asks you a question, what is a architecture? So what might you reply? So you might say like architecture is a design, right? So if we take example of a building, we want a building, right? So what the contractor will do first, he'll tell us, like he'll show us the blueprint. So that blueprint is nothing but your high level view of the building. So if you consider this example, this could be a blueprint of your building, how the building looks from external, right? So this we call it as a architecture. Then we have something called as design. So this is a design for your building. Now design means the internal details, the look and feel. It could also like where the placements of the room should be and the furnitures where it should be kept. So these all things will come into the details, that is minute discussions or details it will come under design. But this one is your architecture, that is high level view. So this is a basic understanding. So what do we mean by software architecture then? So architecture of a system, it provides a high level view of the parts of the system and how they are related to form the whole system. This is a basic understanding, right? The architecture, it partitions the system into logical parts such that each part can be understood independently, and then it describes the system in terms of these parts and relationship between these parts. So if you consider any complex system, it can be partitioned in many different ways. Each of this partition, it provides a useful view, and each it will have different types of logical parts. Again, it holds same true for the software system. If we go by the formal definition of architecture, software architecture, it says the software architecture of a system is a structure or structures of the system which comprise software elements, the externally visible properties of those elements, and the relationships among them. Your software architecture also, it just says the external visible properties of the elements and relationship between the partitions. It does not talk about the internal details of the system. Next, we will see the roles or uses of software architecture. So there are 4 roles or uses. The first one is understanding and communication. Second one is reuse. Third one is construction and evolution, and the fourth one is analysis. We will discuss this one by one. First, we will see understanding and communication. So an architecture description, it is primarily used to communicate the architecture to various stakeholders. Here okay, the stakeholders are nothing but the users who will use the system, the clients who commission the system, the builders who will be building the system, and of course the architects. Okay, now through this architecture, these stakeholders, whoever we discussed now, they will gain the understanding about the high level properties of the system and how the system fulfills the functional and quality requirements. Okay, instead of giving them code and telling them to analyze it or understand it, so it is always better to depict it in a diagram, and it would be a easy way if they want to analyze it, if they want to understand it. Okay, now this your architecture, it will also be act as a vehicle for the negotiation and agreement among the stakeholders. They may have conflicting goals, then this your architecture will come into picture and it will help them for agreement. Next is the reuse. So say suppose if one wants to build a software product in which the existing components may be reused, then this architecture becomes the key point at which the reuse at the highest level is decided. The architecture has to be chosen in a manner such that the components which have to be reused, it can fit properly and together with other components they might be developed. Getting it? How to reuse? Okay. Next, we will see about the construction and evolution. So, architecture partitions the system into parts, right? Into different parts. This we have known. The parts specified in the architecture are relatively independent. They can be built independently. Not only does the architecture guide to the development, it also establishes the constraints. The architecture of the system, it will help in deciding where to add the new features with minimum complexity and effort. So, this will impact the rest of the system in adding the new features. Your architecture can also help in determining which parts of the system that will be affected by the new change or evolution. The last one is analysis. So, many engineering disciplines use model to analyze the design of the product for its cost, reliability, performance, etc. Architecture opens such possibilities for software also. It is possible to analyze or to predict the properties of the system which is being built from its architecture. For example, the reliability or the performance of the system can be analyzed. So, such an analysis can help determine whether the system will meet the quality and performance requirements, and if not, what needs to be done to meet this requirement. So, for example, when building a website for online shopping, so it is possible to analyze the response time or throughput of a proposed architecture, given some assumptions about the request load and the hardware. So, it can be then decided whether the performance is satisfactory or poor, and if not, what new capabilities should be added so that the performance would be improved or it could be satisfactory. Okay. Next, we will study about the architecture views. Now, what is a view? Okay, first we'll consider an example wherein a building is present. Okay, if you have a proper building and you want to see the floor plan of that building. So, to see the floor plan, you will contact the civil engineer, right? So, if you tell the civil engineer to show the floor plan, he will give you a set of drawings and he will explain you. Now, say suppose if you are meeting an electrical engineer and you want to see the electricity distribution for the same building, then he will give you different plan or he will give you different set of drawings. And say suppose if you are interested in safety and firefighting, another set of drawings are used, right? Now these drawings are independent of each other, but they are all about the same building. Now each drawing provides a different view of a building, a view that focuses on explaining one aspect of the building and tries to do a good job. Okay, now the situation is similar to your software architecture. In software architecture, the different drawings are called as views, which represent the system as composed of some types of elements and relationship between them. So, we will basically divide this architecture views into three types. That is, one is module view, the second one is component and connector view, and the third one is allocation view. So, you can see in this diagram, right, the architecture of the system has three views. One is module view, one is allocation view, and one is CNC view. Now, we will study about these views in detail. Okay. Now, what is a module view? So, what happens here is, in a module view, the system is viewed as a collection of code units. Now, these code units, it will implement some part of the functionality, system functionality. So, the examples for this module view could be your packages, class, method, collection of functions, and collection of classes. The relationship between these modules are also code based and depend on how code of a module interacts with another module. That's why here it is given, right? The module view, it tells about the code structures. Next, we have C and C views. That is C and C, nothing but component and connector. So, in a C and C view, the system is viewed as a collection of runtime entities. Objects, a collection of objects, and a process are the examples for these components. Connectors provide a mean of interconnection. Okay, the objects and the collection of objects, processor are the examples of components, and connectors are means of interaction between these components. So, the examples of connectors are pipes, sockets, and shared data. So, CNC view is nothing but it deals with the runtime structures. The last one is allocation view. So, it says software and environmental core structures. Now, what is this? So, this allocation view, it focuses on how the different software units are allocated to resources like your file system, your hardware, and the people. It will also give the properties like which process run on which processor and how the system files are organized in a file system. Getting it? Now we will see the difference between a design and architecture. So the basic understanding what we got in the first or the second slide here is architecture is the high level view, but the design is it gives you the in-depth details of the system. Your software architecture is what we are building. Okay, it deals with what we are building, but your software design, it says how we are building. Getting it? Architecture deals with what we are building, but design, it deals with how we are building it. Okay. The next difference could be the design is really about the modules that eventually exist as a code. During design, low-level issues such as your data structures, file, sources of data, they have to be addressed. While these type of issues like the data structures, what we are using, then what could be the source of data, these all things will not be entertained at architecture level. Your design can be considered as providing the module view of architecture of the system. Again, architecture is a detail in solution. Architecture is a design in solution domain, and it talks about the structure of the proposed system. Architecture is high level design focusing on the only main components. Okay. Next we have a quiz. So, which among the following is not a role of software architecture? Okay, you have got 2 minutes of time to answer this one. Okay, time up. Next, we will study about the component and connector view. That is, the CNC architecture view of the system has two main elements. One is component and the other one is connector. Components are usually the data stores or the computational elements that have some presence during the system execution, and the connectors define the means of interaction between these components. Now CNC view of the system, it defines component, and the component is connected to which other component with what connector. This view, CNC view, it also describes the runtime structure of the system, like what components exist when the system is executing and how they interact during the execution. So CNC structure is usually a graph with components as nodes and connectors as edges. Now we'll look into component. Okay, what is a component? How can we represent it? So as we already know, components are the computational or data stores in the system. These components will have a name. Usually a unique name will be given to these components, and it is used to represent the role of the component or function it performs. You cannot just simply give some name to the components, but how you have to give a name is like it has to represent the role of the component, or it has to represent the function it is performing. Getting it now? So whenever we are representing these components in the architecture view of the system, it is desirable that we should have some different notations. We cannot use the same notations to every component, right? So we have different notations. So what are these notations? So the examples of the components are client, servers, filters, etc.
So the client would be represented in an oval, server in a rectangle, database and application would be represented in this manner. Okay. So now say suppose whenever you are um, drawing a architecture or building a architecture, you might come up with n number of clients or n number of applications in a single system itself. Then how do you do it? So you have to know that the shape of that particular component would remain same, but the naming would be different. So that's why it is said here. So a unique identity has to be given to the components. Next, we will study about the connectors. Now, the different components of the system are likely to interact with each other, then so that they will provide some services of that expected services expected from that system. Now, components exist to provide parts of the services and features of the system, and these must be combined to deliver the overall system functionality. So, for composing a system from its components, information about the interaction between the components is necessary. Now, how can we do this? How can we make two components interact? So, we use connectors for that. All the components must be combined to deliver the overall system functionality, right? So, the connector acts as a media in between two components so that these two components can interact with each other. So what are the examples of these connectors? So okay, before that, how can two components can interact with each other? They could interact with each other using a remote procedure call or using a function call, then using TCP IP ports or using HTTP, right? So we should understand here the connectors may be binary or n-way communication between multiple components. It might not be one to one. Okay. So for example, a broadcast bus may be used as a connector which allows a component to broadcast its message to all other components. Okay. Again, a component, it also should have a name that should describe the nature of the interaction the connector supports. A connector also has a type which is a generic description of the interaction, specifying properties like whether it is a binary or n-way or the types of interfaces it supports. If a protocol is used by a connector type, even it has to be specifically stated. So the examples of the connector would be the bus type connector, right? This one. This is how you this is how you specify the bus type connector. This is for database access. This is for request reply. This is pipe. Okay. Then this is the RPC, remote procedure call. So in our architecture, Whenever you have components, these connectors come into picture whenever the components try to interact with each other, so that if the components interact with one another, then the entire system functionality would be provided. Next, we will see an example of this CNC or component and connector view. We'll take an example of say online survey for students in a campus. So there would be multiple choice questions, set of multiple choice questions, and the system will provide the survey form to the student. Student can fill the form and they can submit it online. We also want that when the user submits the form, or when the student submits the form, he or she is also shown the current result survey, that is what percentage of the students so far have filled which options for different questions. Okay, now the system is best built using the web, right? So this is likely a choice of any developer. Like we will they'll do, they'll build a website for this one. So this is a proper choice. So for this simple system, a traditional three-tier architecture is proposed. Now in this diagram you can see a architecture for that system. It consists of a client which will display the form to the student, so that student can fill the form and submit it, and it will also display the results. The second component is our server, which processes the data submitted by the student and it saves into the database, which is the third component. The server, it also queries the database to get the outcome of the survey and sends the results in a proper way to the client, that is our student. So which will then display the result. Now you have to note here that the client, the server, and the database are all of different types of components. So they are shown in different way. They also have the names, and we also have the connectors in between them, and the connectors are also named properly. Okay. So this diagram makes the different types clear, making the diagram standalone and easy to understand. Getting it? So in the next class, we will discuss the constraints on the same architecture, then what could be the solution of it. So we'll end our session now. Thank you.